Good morning students. Welcome to the chemistry class. Today we shall start with chapter 5, that is states of matter. In the previous chapters we have studied about constituents of matter, that is atoms, ions, molecules, their properties, that is depending on their size, electronic configuration, nature of bonding, types of bonding, etc. Now I will ask some questions. Do we drink a single molecule of water? Can a single molecule of water in the form of ice, do we feel cooling sensation from that? Is it possible for us to consume one molecule of oxygen for respiration? The answer is no, because single atom or molecule cannot decide the state of matter. The state of matter is decided by the bulk property. The bulk property which decides the state of matter. To decide the state of matter, there exists a intermolecular force of attraction. Intermolecular force of attraction. Hence, the magnitude of this intermolecular force of attraction decides the state of matter. Actually, there are three main states of matter. Two more are there, but mainly three states of matter. They are solids, liquids, and gases. The two more states are plasma state and Bose-Einstein condensate, but they are not very common. Let us move to the intermolecular forces. Intermolecular forces are, which is also called as molecular interaction. Molecular interaction. This molecular interaction may be of attractive or repulsive. Attractive or repulsive. But it does not include electrostatic force of attraction. It does not include electrostatic force of attraction, in which cations and anions are bonded together by ionic bond. It does not include hydrogen bond also. It does not include hydrogen bond also, because in hydrogen bond only some atoms are involved. So electrostatic force of attraction and hydrogen bond, they do not come under this one. These intermolecular forces altogether, it is called as van der Waals force. Van der Waals force. The name was given according to Dutch scientist John van der Waals. So it is called as a van der Waals force. There are many types of van der Waals forces. We are going to study three types of van der Waals force. Three types of van der Waals force. They are, first one, London force, or which is also called as dispersion force. The name London force was given according to the or atoms. What do you mean by non-polar molecules? Non-polar molecules means which do not possess permanent dipole moment. Permanent dipole moment, which do not possess permanent dipole moment. We know that dipole moment is nothing but product of charge into distance between the particles. The molecules which do not possess dipole moment, they are non-polar in nature, or this London force also exists between the atoms which are non-polar. For example, non-polar molecules like methane, oxygen, chlorine, etc. Non-polar atoms means like noble gases. Group 18 elements are called as noble gases like helium, neon, argon, krypton, xenon, etc. In the case of noble gases, these are non-polar. They exist as monoatomic. They are monoatomic in nature. Consider two molecules A and B. Atom A or atom or molecule atom B. Since they are neutral molecules, the nucleus is having positive charge which is at the center, while electrons are moving around it. Similarly, in this case also, it is also neutral. Nucleus madhyadalide, electrons are moving around it. But at a short moment, the electron cloud of atom A move towards right, while the nucleus, which is having positive charge, move towards left. But it takes place for a short moment. So I write positive to the left hand side and electron cloud move to the right side, which I have represented by minus. But idenantade kshanika ಸ್ವಲ್ಪ time ಗೆ ಮಾತ್ರ ಹೀಗಾಗುತ್ತೆ. So whenever this happens, here electrons are symmetrically distributed, equal, ಎಲ್ಲ ಕಡೆ equal ಆಗಿ distribution ಆಗಿದೆ. ಇಲ್ಲಿ ಸಹ electrons are equally distribution ಆಗಿದೆ. But short moment ಆಗೋ ಏನಾಗುತ್ತೆ, electron ಎಲ್ಲ right side ಗೆ ಬರುತ್ತೆ, proton left side ಗೆ ಇದೆ. ಈ short moment ಅಲ್ಲಿ ಇದು ಏನು ಮಾಡುತ್ತೆ ಅಂತಂದ್ರೆ it attract the positive charge of B towards itself. So, but remember, this happens only for some time. It is momentary. So, this attract this B, A attract this B for a short moment. This is called as a London force, or which is also called as dispersion force. So, in this case, how the interaction energy varies? The interaction energy here is directly proportional to 1 by 6th power of r. What is r? Where r is the distance between the distance between the particles. Here particles means A and B. So, as the distance decreases, ಇದು denominator ಇದೆ, distance decrease ಆದಾಗೆ interaction energy ಜಾಸ್ತಿ ಆಗುತ್ತೆ. But they are important only till or nearly equal to 500 picometer. And this interaction energy also depends on polarizability. So once again I will explain. This is the first type of van der Waals force of attraction, which is called as London force or dispersion force. exists in the case of which one? Non-polar molecules or atoms. Non-polar molecules means which do not possess permanent dipole moment, like methane, oxygen, chlorine, carbon dioxide, etc. Or atoms like noble gases, which are helium, neon, argon, krypton. Consider two non-molecular particles. I take it as atom A, atom B. Here electrons are symmetrically distributed around the nucleus. Here also electrons are symmetrically distributed around the nucleus. For a short moment, electron cloud of A move towards the right, while the positive charge move towards the left. By the time what happens? It attracts the positive charge of atom B such that there exists a force of attraction which is called as dispersion force or London force. Here, interaction energy is directly proportional to 1 by 6th power of r, where r is the distance between the particles. Okay, so this is about the first type of van der Waals force. Okay, let's move to the next type of van der Waals force, that is second type. The second type is dipole-dipole force. As the name indicates, dipoles means two poles, means it contains plus and minus charge. So we can say that dipole-dipole force is present in the molecules which possess permanent dipole moment. For example, HCl molecule. We know that in the case of HCl molecule, chlorine is more electronegative, so it possesses delta minus. Delta means what? Partial negative charge, while hydrogen possesses partial positive charge. Why chlorine possesses partial negative charge? Since it is more electronegative. But hydrogen is less electronegative compared to chlorine, so it possesses partial positive charge. This partial charge is less than unit electric charge. Unit electric charge, that is 1.6 charge on electron. Unit electric charge means charge on electron 1.6 into 10 to the power minus 19 coulomb. So let's take the example of hydrogen chloride. In the case of hydrogen chloride, I write H on the left hand side which possesses partial positive charge and Cl on the right hand side which possesses partial negative charge. We know that opposite charges attract each other, so it attracts another HCl molecule. Why? E negative charge, E positive charge attract one another. So opposite charge ಆದ ಕಾರಣ they attract each other. This is called as dipole-dipole force. This is called as dipole-dipole force. In this case also, interaction energy, how it varies with the distance between them. Here two types of variation are there. One is interaction energy directly proportional to 1 by 3rd power of r, where r is the distance between the particles. Distance between the particles. But remember, this is in stationary polar molecule. This is in the case of stationary polar molecules. What about in the case of moving polar molecules? In the case of rotating or moving polar molecules, interaction energy is inversely proportional. R to the power 6 inversely 1 by R6. Direct means R to the power 6. Here inversely proportional to R to the power 6, where R is the distance centimeter, where R is the distance between the particles. Besides this dipole-dipole force, these molecules also exhibit London force. So cumulative effect increases. Means the cumulative effect means the total effect increases. So from this also we can say that as the distance between them decreases, the interaction energy increases because it is inversely proportional. Interaction energy is inversely proportional to R to the power 6. So once again I explain. The second type is dipole-dipole force. Dipole-dipole force exists in the case of molecules which possess permanent dipole moment. For this, we shall take the example of HCl. In the case of HCl, H possesses partial positive charge, chlorine possesses partial negative charge. Since chlorine is more electronegative, here HCl one molecule, HCl another molecule. The negative charge attracts the positive charge, so Cl attracts the H. So intermolecular attraction is present. Now, interaction energy here is proportional to 1 by R to the power 3, where R is the distance between the particles. But remember, this is in the case of stationary polar molecules. In the case of rotating polar molecules, interaction energy proportional to 1 by R to the power 6. Anyhow, in both the cases, as the value of R decreases, the interaction energy increases. Besides this dipole-dipole force, these molecules also possess London force, so cumulative effect increases. Let us move to the third type, that is dipole-induced dipole force. Dipole-induced dipole force. Here, this is possible in the between the molecules where one is having permanent dipole moment and another one is no permanent dipole moment. Understood? Dipole means two poles. Induced dipole means this dipole creates dipole in another molecule which is neutral in nature. So let us take the example of molecule A, which possess partial positive, partial negative charge. Any molecule we can take, and another molecule which is neutral in nature. So neutral means electrons are symmetrically distributed around the nucleus. This negative charge attracts the opposite charge. Opposite charge present here is nucleus, positive charge attracts this one such that A distorts the electron cloud of B. So in the case of B, the positive charge comes close to A and electron move towards the right. Okay, so this force of attraction exists between them is called as dipole-induced dipole force. Why it is called induced dipole force? Because A is already possess dipole moment, permanent dipole moment, but B is neutral, non-polar in nature. One is polar, another is non-polar. This dipole force ante. Okay, so this force of attraction is called as dipole-induced dipole force. In this case also, interaction energy is directly proportional to 1 by r to the power 6, where r is the distance between the particles. Besides this also shows London force. Here also, in this case also, the cumulative effect increases. Okay. So third one, once again I explain, dipole-induced dipole force. In that case, ಏನಾಗಬೇಕು, ಒಂದಕ್ಕೆ ಕಾಮನ್ ಡೈಪೋಲ್ ಇರಬೇಕು, ಇನ್ನೊಂದು ನ್ಯೂಟ್ರಲ್, ಯಾವುದೇ ಚಾರ್ಜ್ ಡಿಫರೆನ್ಸ್ ಇರಬಾರದು. ಅಟ್ ಎ ಶಾರ್ಟ್ ಮೊಮೆಂಟ್ ಏನಾಗುತ್ತೆ, ದಿಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಅಟ್ರಾಕ್ಟ್ ದಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಏನಿದೆ, ನ್ಯೂಕ್ಲಿಯಸ್ ಇದೆ, ಪ್ರೋಟಾನ್ ಅಟ್ರಾಕ್ಟ್ ದಿ ನ್ಯೂಕ್ಲಿಯಸ್. ಸೊ ಅದೇನಾಗುತ್ತೆ, ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಬರುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ dipole-induced dipole force. Here also interaction energy is directly proportional to 1 by r to the power 6, where r is the distance between the particles. So from this it is clearly understood that as the distance between them decreases, when they come closer to each other, the interaction energy increases because they are inversely proportional to each other. Here also, other than this, these molecules show London force, so cumulative effect is increases. The next concept is hydrogen bond. As we studied in last chapter, hydrogen bond is dipolar in nature because it exists between hydrogen atom and more electronegative atoms. More electronegative atoms like fluorine, oxygen, chlorine, etc. Sulfur also possible. Okay. It can be represented as hydrogen bond in the case of hydrogen fluoride. We know that hydrogen is electropositive compared to fluorine, while fluorine is electronegative, which is the highest electronegative element in the periodic table. The intermolecular hydrogen bonding present between hydrogen fluoride molecule can be represented as one hydrogen fluoride molecule connected to another hydrogen fluoride molecule. Similarly, it continues. Now, this bond exists between two hydrogen fluoride molecules, which is called as intermolecular hydrogen bond. As we know, H possess partial positive charge, fluorine possess partial negative charge. Same case continues. Here, this negative charge attracts the positive charge of hydrogen of another hydrogen fluoride molecule. So, it is represented by dotted line. So, hydrogen bond is represented by which one? Dotted line. Similarly, this negative charge attracts positive charge. So, hydrogen bond. So, hydrogen bond. Okay. So, we can say that hydrogen bond does not come under van der Waals force because it involves only some particles like this one. It is not common in every case. So, it is does not come under which one? Van der Waals force. So, this is about the hydrogen bond. Next one, let us move to the next concept, that is thermal energy. Thermal energy depends on movement of proportional to kinetic energy. Kinetic energy so kinetic motion ಅಂದ್ರೆ movement ಇಂದ ಬರುವ energy. So kinetic energy. So we can say that from this, as the temperature increases, as the temperature increases, kinetic energy of molecules also increases. As the temperature increases, kinetic energy of the molecules increases. Now we have to compare intermolecular force versus thermal energy. Intermolecular force of attraction cling the molecules to bond together, while thermal energy separates the molecule, means such that atoms move apart. So we can say that they are reciprocal to each other. Andre one increase or one decrease. Okay. Here, in the case of solids, liquids and gases, intermolecular force of attraction is more in the case of solid. So we can write the variation of intermolecular forces predominance can be written as it varies like this. So this is predominance of intermolecular force of attraction. Intermolecular force of attraction. Similarly, the predominance of thermal energy. As I said, as the intermolecular force of attraction, molecules come closer. So, in the case of gases, molecules are away from each other. In the case of liquid, they are little less closer, while in the case of solid, they are more closer. So, as the thermal energy increases upon increasing the temperature, what happens? Predominance of thermal energy varies like this. Solid very least because molecules come close to each other. In the case of liquid, little away. Gas still away. So we can say that predominance of thermal energy varies like this. As I said in the beginning, the molecular interaction may be repulsive or attractive nature. Attractive nature already explained. How it becomes repulsive? The repulsive force between the molecules is due to two reasons. One is whenever the electron cloud of both the atoms come close to each other, they repel each other. When electron cloud between the atoms of molecule come closer, then the molecules or atoms may repel. Another reason is when their nucleus come close to each other, because positive charges repel each other. So whenever nuclei of particles come closer to each other. So these are the two reasons for repulsive force. We know that in the case of gases, the repulsive force is more. So repulsive forces is more in the case of gas than liquid than solid. Let us move to the gaseous state of matter. Gaseous state of matter. The atmosphere where we live, which contains mixture of gases, they have some common properties. The characteristics of gases first one is they are highly compressible. Compressible ಅಂದ್ರೆ ಏನು? ನಾವು ಜಾಸ್ತಿ ಪ್ರೆಷರ್ ಹಾಕುವಾಗ, ಒತ್ತಡ ಹಾಕುವಾಗ ವಾಲ್ಯೂಮ್ ಜಾಸ್ತಿ ಇದ್ದದ್ದು ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸೊ ದೇ ಆರ್ ಹೈಲಿ ಕಂಪ್ರೆಸಿಬಲ್. ಸೆಕೆಂಡ್ ಒನ್, ದೇ ಎಕ್ಸರ್ಟ್ ಪ್ರೆಷರ್. They exert pressure in all the directions. ಅಂದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದು ಕಂಟೈನರ್ ಅಲ್ಲಿ ನಾವು ಗ್ಯಾಸ್ ಅನ್ನು ತಗೊಂಡ್ರೆ ಅದೇನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಎಲ್ಲಾ ಕಡೆಯಲ್ಲಿ ಈಕ್ವಲ್ ಆಗಿ ಪ್ರೆಷರ್ ಇದೆ. ಒಂದು ಕಡೆ ಜಾಸ್ತಿ ಇನ್ನೊಂದು ಕಡೆ ಕಡಿಮೆ ಅಂತಾರಲ್ಲ, ಎಲ್ಲ ಕಡೆ ಈಕ್ವಲಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುತ್ತೆ. ಸೊ ದೇ ಎಕ್ಸರ್ಟ್ ಪ್ರೆಷರ್ ಇನ್ ಆಲ್ ದಿ ಡೈರೆಕ್ಷನ್ಸ್. ಥರ್ಡ್ ಒನ್, ಡೆನ್ಸಿಟಿ. Density of gases are less than solids and liquids. Density ಅಂದ್ರೆ ಸಾಂದ್ರತೆ. ನೀವು ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದಿಸ್ ಮಚ್ ಅಮೌಂಟ್ ಆಫ್ ಗ್ಯಾಸ್ ಅನ್ನು ತಗೊಂಡ್ರೆ ಅದರ ವೆಯ್ಟ್ ತುಂಬಾ ಕಡಿಮೆ ಇದೆ. ಅಷ್ಟೇ ಅಮೌಂಟ್ ಆಫ್ ವಾಟರ್ ಅಥವಾ ಸಾಲಿಡ್ಸ್ ಅನ್ನು ತಗೊಂಡ್ರೆ ಅದರ ವೆಯ್ಟ್ ಜಾಸ್ತಿ ಇದೆ. So we can say that ಸಾಂದ್ರತೆ, density is less than solids and liquids. What about volume and shape? If you take the volume and shape of the gas, ಅದು ಗ್ಯಾಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರಲ್ಲ, ನೀವು ಯಾವ ಕಂಟೈನರ್ ಅಲ್ಲಿ ತಗೊಂಡಿದ್ದೀರಾ ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. So volume and shape of the gases depend on shape and volume of container. Volume and shape of gases depends on volume and shape of container. What about their next property? They mix evenly in all proportional. Mix evenly in all proportions. All proportions without any external ಮೆಕ್ಯಾನಿಕಲ್ ಏಡ್. ಅಂದರೆ ಯಾವುದೇ ಒಂದು ಮೆಷಿನ್ ನ ಯೂಸ್ ಇಲ್ಲದೆ ನಾವು ಮಿಕ್ಸ್ ಅಪ್ ಮಾಡಬಹುದು. ಮೆಕ್ಯಾನಿಕಲ್ ಅಸಿಸ್ಟೆನ್ಸ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯಾವುದಾದ್ರೂ ಗ್ಯಾಸ್ ಮಿಕ್ಸ್ ಅಪ್ ಮಾಡಬೇಕಿದ್ರೆ ನಾವು ಎಕ್ಸ್ಟರ್ನಲ್ ಅಸಿಸ್ಟೆನ್ಸ್ ಬೇಕಂತಿಲ್ಲ. ಈ ನಾರ್ಮಲಿ ನಾವು ನೇಚರಲ್ಲಿ ನೋಡಿದ್ರೆ ಸಹ ಏನಾಗಿದೆ, ಈಗ ಆಕ್ಸಿಜನ್ ಕಂಬೈನ್, ನೈಟ್ರೋಜನ್ ಎಲ್ಲ ಕಂಬೈನ್ ಆಗಿರುತ್ತೆ. ಅದಕ್ಕೆ ನಾವು ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಬೇಕಂತ ಇಲ್ಲ. ಸೊ ದೀಸ್ ಆರ್ ದಿ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಈಕ್ವಲ್ ಗ್ಯಾಸಸ್. ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಆಫ್ ಗ್ಯಾಸಸ್ ಹೈಲಿ ಕಂಪ್ರೆಸಿಬಲ್. ನೀವು ಜಾಸ್ತಿ ಒತ್ತಡ ಹಾಕಿದ್ರೆ ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಅದೇ ರೀತಿ ನೀವು ಸಾಲಿಡ್ ಅನ್ನು ಜಾಸ್ತಿ ಒತ್ತಡ ಹಾಕಿದ್ರೆ ಸೈಜ್ ಅನ್ನು ಚಿಕ್ಕದು ಮಾಡಲಿಕ್ಕೆ ಆಗಲ್ಲ. ನೆಕ್ಸ್ಟ್, ಎಕ್ಸರ್ಟ್ ಪ್ರೆಷರ್ ಇನ್ ಆಲ್ ಡೈರೆಕ್ಷನ್. ನೀವು ಒಂದು ಕಡೆ ಗ್ಯಾಸ್ ಅಂತ ತಗೊಂಡ್ರೆ ಸಹ ಅದು ಸ್ಪ್ರೆಡ್ ಆಗಿ ಎಲ್ಲ ಕಡೆ ಹೋಗುತ್ತೆ. ಸೊ ಎಕ್ಸರ್ಟ್ ಪ್ರೆಷರ್ ಇನ್ ಆಲ್ ದಿ ಡೈರೆಕ್ಷನ್ಸ್. ನೆಕ್ಸ್ಟ್, ಡೆನ್ಸಿಟಿ ಇಸ್ ಲೆಸ್ ದನ್ ಸಾಲಿಡ್ಸ್ ಅಂಡ್ ಲಿಕ್ವಿಡ್ಸ್. ಈಕ್ವಲ್ ಅಮೌಂಟ್ ಆಫ್ ವಾಲ್ಯೂಮ್ ಅಲ್ಲಿ ತುಂಬಿಸಿಕೊಂಡಿದ್ರೆ ಪರ್ಟಿಕ್ಯುಲರ್ ವಾಲ್ಯೂಮ್ ಅಲ್ಲಿ ಗ್ಯಾಸ್ ಅನ್ನು ಲಿಕ್ವಿಡ್ ಸಾಲಿಡ್ ಅಂತ ತಗೊಂಡ್ರೆ ಗ್ಯಾಸ್ ವೇಟ್ ಮಾಡೋದು ವೆರಿ ಲೆಸ್, ಅದರ ವೇಟ್ ತುಂಬಾ ಕಡಿಮೆ ಬರುತ್ತೆ. ವೈಲ್ ಸಾಲಿಡ್ಸ್ ಅಂಡ್ ಲಿಕ್ವಿಡ್ಸ್ ಜಾಸ್ತಿ ವೇಟ್ ತೋರಿಸುತ್ತೆ. ವಾಲ್ಯೂಮ್ ಅಂಡ್ ಶೇಪ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ವಾಲ್ಯೂಮ್ ಅಂಡ್ ಶೇಪ್ ಆಫ್ ದಿ ಕಂಟೈನರ್. ನೀವು ಯಾವ ಕಂಟೈನರ್ ತಗೊಂಡ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೀವು ರೆಕ್ಟಾಂಗ್ಯುಲರ್ ಶೇಪ್ ತಗೊಂಡ್ರೆ ಅದು ರೆಕ್ಟಾಂಗ್ಯುಲರ್ ಶೇಪ್ ಅಲ್ಲಿ ಫುಲ್ ಸ್ಪ್ರೆಡ್ ಆಗಿ ಆ ಶೇಪ್ ಅಲ್ಲಿ ತೋರಿಸುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಯು ಟೇಕ್ ಓವಲ್ ಶೇಪ್ ಕಂಟೈನರ್, ಇಟ್ ಟೇಕ್ಸ್ ಓವಲ್ ಶೇಪ್. ಲೈಕ್ they mix evenly in all proportions without any mechanical resistance. ನಾವು ಯಾವುದೇ ಒಂದು ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡದೆ ಅವುಗಳನ್ನು ಮಿಕ್ಸ್ ಅಪ್ ಮಾಡಬಹುದು, ಅವುಗಳೇ ಮಿಕ್ಸ್ ಅಪ್ ಆಗ್ತವೆ. ಸೊ ದೀಸ್ ಆರ್ ದಿ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ವಿಚ್ ಒನ್ gases. Gases have many common characteristics. Their characteristics depends on four physical quantities. They are pressure, gas laws. Pressure, volume, temperature and mass are the four physical properties. The correlation between them is generalized. This generalization is called as gas laws. So let us study some of the gas laws. Among them, the first one is Boyle's law, which relates pressure and volume, hence it is called as pressure-volume relationship. It was given by a scientist called Robert Boyle, hence it is called as Boyle's law. It states that the statement of the law is at constant temperature, the volume of given mass of gas, means it may contain n molecules or n number of moles. The volume of given mass of gas is inversely proportional to the pressure. Inversely proportional to the pressure. See, at constant temperature, and the temperature change madikilla constant irಬೇಕು. The volume of given mass of gas is inversely proportional to the pressure. So, mathematically, it can be represented as V, volume V is inversely proportional to P. This is proportional symbol, inversely until 1 by P. Inversely proportional to P. So V is proportional to 1 by P. But remember, at constant temperature T. If you remove this proportionality symbol to add equal sign, we have to use a constant, that is K. So I write, but K should be the numerator. So I write K by P, where K is a constant. It depends on pressure and volume. Or if you bring this P to the left hand side, PV is equal to K, which is a constant. So from this we can write that it is a product of pressure and volume. It is constant. If there is a product, it is constant and it increase or it decrease or it decrease or it increase. So that is why that is inversely proportional. Inversely proportional ಒಂದು increase ಆಗುವಾಗ next denominator ಇದು decrease ಆಗುತ್ತೆ ಅಥವಾ ಇದು decrease ಆಗುವಾಗ ಇದು increase ಆಗುತ್ತೆ. So they are called as inversely proportional. So ಅದಕ್ಕೋಸ್ಕರ product of pressure and volume remain constant. ಇದು increase ಆಗುತ್ತೆ, ಇದು decrease ಆಗುತ್ತೆ, value change ಆಗಲ್ಲ, ಇದು constant ಆಗಿರುತ್ತೆ. So from this mathematical form we can also state the Boyle law as at constant temperature, at constant temperature, product of volume and pressure remain constant. Product of pressure and volume remain constant. I will plot a graph of volume along x-axis while pressure along y-axis. So what should be the shape of the graph? One increase ಆಗುವಾಗ ಇನ್ನೊಂದು decrease ಆಗುತ್ತೆ. So this is at zero value. So shape of the graph should be like this, decreasing nature. Okay. So if it is taken as 200 Kelvin for particular gas, as the temperature increases, see here, this is at 400 Kelvin temperature and this is at 600 Kelvin. As the temperature increases, graph becomes up. Okay. So this is the variation of pressure and volume. Here, remember here, this is a graph for same gas but at different temperature. This is called at constant temperature, that is 200 Kelvin. This is at 400 Kelvin. This is at 600 Kelvin. So whenever pressure and volume are plotted, so decreasing nature. Okay, decreasing nature of the graph we can observe. From this we can also note that as the pressure decreases, the volume doubles. As the points we are getting like this means, as the pressure decreases, the volume becomes more, double, exactly double. Okay. If you plot pressure versus 1 by V, I take again pressure along y-axis and 1 by V in terms of meter cube. Here bar, here meter cube, unities, here also bar and meter cube. If you plot the graph, how they are related? 1 by V and V are directly proportional. Remember here, V and V are inversely proportional, but 1 by V and V are directly proportional. So we can say that it increases directly. So it passes through origin. For example, if we take, let us take this is at T1 Kelvin, this is at T2 Kelvin, this is at 3 Kelvin, T3 Kelvin, sorry, T3 Kelvin. Okay. So as the temperature increases, the graph may not become straight, but in this case we are getting straight line passing through the origin. Since in this case graphs are drawn at constant temperature, so these are called as isotherms. These straight lines are called isotherm. Isotherm means graph drawn at constant temperature. So these are called as isotherms. According to Boyle's law, we know that V is equal to K by T, where K is a constant, or P into V is equal to K, a constant. Now, let us take, let V1 be the volume of given mass of a gas at constant temperature. And pressure will be P1. If pressure is increased to P2, pressure is increased to P2, then what happens to volume? Volume decreases. Then volume decreases to V2, but constant temperature, at constant temperature for given mass of pressure. So from this we can write P P1 V1 is equal to P2 V2, or if you write P3 V3, that also same, P3 V3, a constant. By rearranging these terms, we get V1 by V2 is equal to P2 by P1. Very, very important. V1 by V2 is equal to P2 by P1. Why? On increasing the volume, pressure decreases. Or increasing the pressure, volume decreases. That is why V1 by V2 is equal to P2 by P1. We already studied the graph of variation of volume and pressure. Okay, we know that if you take pressure along y-axis and volume along x-axis, we will get a curve sloping downwards at constant temperature. So already we drawn for three different temperatures, 200 Kelvin, 400 Kelvin and 600 Kelvin. And we have already plotted the pressure versus 1 by V, means pressure along y-axis, 1 by volume along x-axis. That time we will get a straight line passing through origin. But at high pressure, Boyle's law deviates, means we may not get straight line. So at high pressure, they deviate from that. Let's apply the density. We know that density D is equal to mass by 1. Let's substitute V is equal to, from this equation, K by P, such that we get D is equal to M by V. V is nothing but K by P, so we will get M by K into P, right? Or we can write D is equal to M by K into P. M is constant since we consider given mass of gas, so M is constant. K is also constant. A constant divided by constant is always constant. So D is proportional to P, or D is equal to K dash into P. What is K dash? K dash is also constant, where K dash is constant. So from this expression, we can conclude that density is directly proportional to P. How? If you remove this constant, B is proportional to P needed. So density is directly proportional to pressure. So we can say that from this or from Boyle's law, at constant temperature for given mass of gas, density varies with the pressure. As density increases, pressure also increases. Okay. So once again, according to Boyle's law, V is equal to K by P. Already we studied. Product of pressure into volume is equal to K, which is a constant. Let us consider V1 be the volume of given mass of a gas at constant temperature, and pressure will be P1 by the K. If pressure is increased to P2, then volume decreases to V2. Remember, pressure increases, volume decreases. They are inversely proportional to each other. So from the Boyle's law, you can say that P1 V1 is equal to P2 V2. It is a constant. Or rearranging these terms, we will get V1 by V2 is equal to P2 by P1. Now, how this density and pressure are related? Let's see. We know that density is nothing but mass by 1. According to Boyle's law, we know that volume is nothing but K by P, where K is a constant. So substitute this V is equal to K by P in the density equation. So M by V is equal to M by K by P. So P goes to numerator, M by K into P, which is a constant. M by K is a constant. So D is equal to K dash into P, where K dash is a constant. from this we can say that density is directly proportional to pressure P. So when density increases, pressure P also increases.